Hi, this is Mike Lopez, and in this video we're going to be looking at hyperbolic functions. So where do these hyperbolic functions actually appear in electrical engineering? Well, the most obvious answer I can give to you is to look at a long transmission line. Okay, TX for transmission. So it's a nice long transmission line going from A to B, and also we're going to have a ground perhaps here, just abbreviate that, GND, which we can also use as an x-axis to plot a voltage graph. Now, assuming that was a nice ideal transmission line, we should have a nice steady voltage from A to B. But in the real world, of course, things aren't like that, and we have things like series resistance, we have inductance in the line, we also have some capacitance from the line to ground, and some conductance, which we normally turn G. You can think of it as a resistor between the two. Okay, so we got RL, C and G. And that also appears here and here and here, so we can put it into unit lengths of line. So what does this actually mean then for the voltage on the line? Well, let's draw a graph. We can have the line voltage VL here. We have our x-axis running along the ground, and the type of graph that we actually see looks a bit like this. That sort of shape. What is that shape? Well, it's the voltage along the length of the line, and it's Koch shaped. Koch shaped. Okay, and this Koch means a hyperbolic cosine. Okay, what I'd like to do is to have a look and see what a hyperbolic cosine actually looks like if we were to plot one. Okay, go back to black, let's put some axes in. Here we are. This is going to be Y, this can be X. Let's see if we can plot a hyperbolic cosine. What we get is something that looks a bit like a hanging cable. Okay. Maybe we should write that in here for you. So a hanging cable looks a bit like that, certainly not semicircular. Okay, and you could also see this red curve here from power transmission lines between pylons, for example, that sort of shape. Okay, and the important point to note for a cosine is here is the point 1. Okay, so this is a graph of y equals the Koch of x. What if we were to plot a graph of y equals the sine of x? Okay, so the hyperbolic cosine, I should say, it's a bit of a tongue twister. And well, what we find with this thing is that we have this sort of shape like this. Okay, and that's going to be y equals the sine, as we term it, the sine of x. Okay, let's have a look at a quick example. How about y equals 80 Koch x over 20. What's that going to look like? Well, it's going to look a bit like, it's a cosine function, of course, so you would expect it to be something like this. There's the cosine shape, and we'd have a height of 80 there. And what we might be particularly interested in, a question might ask us to work out what's the value of y when x was, say, minus 35 or potentially plus 35. What is this y value here? That one there. Okay, we'll put more formally. We can write, here's the question again. Let's scroll down slightly. So what's y when x equals 35? Okay, a couple of ways you can do that. You can plot and observe values, and you use the graph simulator as recommended to do those plots. So plot and observe the value, or we could have a go at the analytical method. Okay, we can find y analytically. Which we can do now. Let me change color to make it more readable for you. We've got y equals 80 cosh x over 20. Therefore, let's divide. Not divide. Why don't we just put in values? Okay, so you're going to have y equals 80 cosh x is 35 over 20. 35 over 20 sounds a bit like 1.75. Get the cosh of that, multiply by 80, and you should find that y comes out to be 237 and a bit. Okay, so almost equal to 237. Right. Next thing then, see if we can switch it round a little bit and ask ourselves this question. What's x when y equals 100? Okay, so what's x when y equals 100? So that's the other way around. We're going to need some transposition. If we're not doing plot, which you could do, you've got the plot option, and you could read it off from the graph, or you could find it analytically. Okay, and to do that we need to transpose first, which I'm about to do. Okay, so we started off, of course, with, come down a bit more, we started off with y equals 80 cosh x over 20. Okay, what we're doing is we're targeting x, so we want something that says x equals blah blah blah. In which case, it's probably a good idea we can move this 80 somewhere, and perhaps if you divide both sides by 80, the 80 will go over there. So you will then end up with y over 80 equals cosh of x over 20. Okay, if we were to then consider that the x is wrapped inside of that cosine function there, so what we can do is say to ourselves, okay, so why don't we take the cosh minus 1 of both sides? Okay, let's do that. So cosh minus 1 of y over 80 equals the cosh minus 1 of what was on the right hand side, which was cosh x over 20. And by now, looking at how to obliterate functions, you hit them at their inverse. So this cosh minus 1 is going to obliterate that cosh. So we end up with x over 20 equals cosh minus 1 y over 80. Change colour, therefore multiply both sides by 20. X equals 20 times the cosh minus 1 of y over 80. And in this particular problem, we're asked to solve when y equals 100. Okay, therefore x is equal to 20 cosh minus 1 y, which is 100, over 80, like so. Okay, 100 over 80 is 1.25, so you find the cosh minus 1 of 1.25 and you multiply that by 20. Okay, and you should be getting an answer around about 13.86. Yep. Okay, so let's move on and let's have a look at this problem actually on the graph simulator.